Solve the following linear system in 3 ways. Linear system. Remember, the linear system, basically the linear function is y is equals to mx plus c. You could use other letters, but the principle stays the same. Y is equals to mx plus c. That's what I'm using. So you then, if you solve this linear system in 3 ways, you can use graphing, substitution, and elimination. Now, how many equations do you have? You have 2 equations. And these equations basically are independent of each other. So let's start solving. So we'll solve one equation at a time. Let's start off with the first equation, right? So x minus y is equals to 5, right? So that means that you must turn that into standard form by transposing the y to the other side and the 5 to the other side. Therefore, x will be equals to negative 5, which was positive on this side, equals to y. Now, this is a standard form. It's just that it's written indirectly. So now we are going to write it directly by writing y is equals to x minus 5. Having done this, you already can see that, okay, you have a coefficient of x, which is the slope. In this case, it's 1. Right? Here, the 1 is there. So you need to write it also in a form of 1 over 1, because you are going to be graphing this, which is rise over run. Rise over run. Remember that. Now we'll deal with the second equation, which is now, the second equation is 3x plus y is equals to 3. You saw it in the first page. Now, how are you going to do this? You're going to transpose the 3x to the other side. Now your standard form will be y is equals to negative 3x plus 3. Again, you have a situation, right? The situation that you have is that you have a slope of negative 3. Now, if you have a slope of negative 3, you need to write the slope in a form of negative 3 over 1 so that you are able to graph it. Now, we will then quickly look at the graph in this regard. The graph here is the graph. You basically are going to look at your 2 lines. You have a line that goes from right to left, and the other one goes from left to right. Now, you ask yourself, how was this line plotted? Now, firstly, you will then go back to the equation and look at your equation. Now, for the first equation, you will clearly see that you have a negative 5 as the y-intercept, right, for the first one. So you have the negative 5 as the y-intercept. And for the second one, you will have then the positive 3 as your y-intercept. Now, let's go back to the graph. How do we plot that? So we go to the y-intercept for the 5. Where is the y-intercept? It's the negative 5, right? We are together in that. So rise over run means that whatever you have as a solution here, which is 1, you rise once, then you run once. You rise once, you run once. You rise once, you run once. So you go to the y-intercept. You rise once, you run once. Then you plot. You rise once, you run once. You plot. You rise once, you run once. You plot. You rise once, you run once. You plot. And so forth up the line. So the line basically goes from what? From the right hand side to the left. Because when you draw the line, it goes down from what? From the right to the left. Now let's look at for the equation 2, the second equation which we have. Now, the second equation has a gradient or a negative slope. So when you have a negative slope, you know that you are going to be going down. Positive slopes means you're going up. Negative slopes means you're going down. So let's look at the negative slope, how it works. You first go to where your y-intercept is. Now in this case, you have a positive 3. Now where is positive 3 on the y-axis? On the y, on the graph, or on the Cartesian plane, so to speak. It's obviously above. So the line above 3, you go. How many times do you have to go down? Remember, if your slope is a negative, you go down. So 1, 2, 3 times you go down, you run once. Remember, it's 3 over 1. Again, it goes down 1, 2, 3, you run once. 1, 2, 3, you run once again. So therefore the line will go from your left hand side to the right hand side, from top to bottom. But then I'm sure you have this in check, and you understand what I'm talking about. So for this part of the question, we have answered the fact that when you are graphing, this is your points will be where the lines intersect. And where do they intersect? They intersect at positive 2x and negative 3. You therefore have your point of intersection at positive 2x and negative 3, which should be the same whenever if you are going to use the method of elimination and substitution. We are going to prove that, of course. Okay, now we are going to solve the linear system using the method of elimination. Okay, as we start solving with the method of elimination, we look at two equations. First equation is x minus y is equals to 5. And then you have your second equation, which is what? Equation 2 is 3x plus y is equals to 3. So to solve, you know that these need to eliminate. Now to eliminate, certain things need to be the same. Your y, for example, eliminates easily with the y. You therefore can add x and x, you get 4x. You add 5 and 5, you get 4a. And then you get your x is equals to 2. Substitute the x into equation 1 or 2. After having done that, you will then write the equation you're going to substitute into x minus y, which is the easier option, is equal to 5. Where there is an x, you put a 2 and you start solving for y. Now 2 minus y is equals to 5. We can easily solve this by transposing the y to the other side and the 5 to the other side. You will then get 2 minus 5 is equals to y, and y is therefore equal to negative 3. As you can see, the purpose was for us to find the point of intersection. Remember how we found the point of intersection when we were using graphing? We found that the point of intersection was 2 and negative 3. Now we have the same thing here. We have x is 2 rather, and then y is equals to negative 3. Now, last but not least, we'll be solving using the method of substitution. So we're solving the following linear system using the method of substitution. Now you have two equations. Using the method of substitution, you will then have to have your first equation as per usual, which is x minus y is equals to 5, right? So this is equation 1. For equation 2, for your second equation, you'll have the same equation, which is 3x plus y is equals to 3, if you still remember. Here now the trick is that you need to create or isolate one of the variables in one of these equations. So to do that, you create an equation called equation 3 by isolating one variable. So you'll isolate the x to start off with, where you'll have x then is equals to y plus 5. Now, where there's an x, you are going to then put y plus 5 in the second equation. So you substitute the third equation into what? Into the second equation. Now, once you start doing this, you are solving the problem. You will go then 3. Instead of writing x, you are going to write y plus 5. And then you will have your plus y, which is then will be equals to 3. So you are moving right along. Then you distribute the 3 into the brackets. So 3 times 5 is 15. 3 times y is then 3y. Now you can start simplifying. So you rewrite the rest of the equation. Y is equals to 3. When you simplify, you have like terms, which is 3y plus y, which will give you 4y. You transpose the 15 to the other side, which will be a negative 15. And if you minus the 3, you will get negative 12. Now, it's easy this way because you know your y will then be divided on both sides by 4, so that you can get negative 3. This is only the y value. Now, you will use this y in the equation 3 or any one of these equations for that matter. But equation 3 is easier because it's already isolated the x. So you will then, where there's a y, you put a negative 3. If you put a negative 3 where there's a y, your answer will be 2. X will be equals to 2. Therefore, y is negative 3 and x is equals to 2. And that way you have solved the linear equation using the method of substitution. And all your answers are the same. For all equations, for elimination, you get the same. And then for graphing, you also get the same. For graphing, you need to go to the graph. So 2 and negative 3. So you have the same solutions for everything. That's your answer for question 1.